Welcome to MEP Tech and Travel by SRJ. My name is Sirajuddin. I'm an MEP engineer working in Oman. Today I'll explain how to design an electrical system for an office space. Before we dive into the power requirements, let's take a moment to understand the variety of equipment typically found in an office and their respective power needs. Offices are hubs of activity, buzzing with devices that need power to keep things running smoothly. From the computers that are the lifeblood of productivity to the coffee machines that keep everyone fueled, every piece of equipment plays a vital role. Take printers, for example. They might not be running constantly, but when they do, they can draw a significant amount of power. A typical office printer can consume around 400 watts. It's crucial to account for these intermittent loads to ensure your system can handle peak demands without a hitch. Now, consider the other essentials. We have desktop computers that generally consume around 150 to 300 watts each, monitors that add another 20 to 60 watts, and don't forget about the network devices like routers and switches, which also draw power continuously. As we move forward, we'll see how all these individual pieces add up to form the total power requirement for your office. Understanding each component helps in crafting a reliable and efficient electrical system. Let's now proceed to the detailed breakdown of power requirements for office floors. Welcome to our guide on designing a three-phase distribution board. Let's start with the power requirements. Every office needs it, and getting it right starts with knowing what you need. We're talking about everything that consumes electricity: computers, printers, coffee machines. First up, total twin sockets in the floor is 100 nodes. Consider 400 watts each. Consider 6 AC units, 2,000 watts each. Finally, consider the total light load, approx 5,000 kilowatts. Good lighting is crucial for productivity. Add up these all power requirements. This gives you your total power load. Remember, this is about safety and efficiency. We don't want any overloaded circuits tripping breakers or causing fires. A well-designed electrical system is a safe and efficient one. And that's what we're all about. Let's break it down further. A typical office computer consumes around 150 watts. If you have 50 computers, that's 7,500 watts. Printers vary, but a standard office printer uses about 500 watts. For 10 printers, that's 5,000 watts. Don't forget the coffee machines. Each one can use up to 1,000 watts. If you have 5, that's 5,000 watts. Lighting is another big one. Modern LED lights are efficient, using about 10 watts per square meter. For a 500 square meter office, that's 5,000 watts. Air conditioning is crucial for comfort. Each unit can use 2,000 watts. For 6 units, that's 12,000 watts. Adding all these up gives you a comprehensive view of your power needs. This detailed calculation ensures you design a system that meets all your requirements. Remember, this is about safety and efficiency. We don't want any overloaded circuits tripping breakers or causing fires. A well-designed electrical system is a safe and efficient one. And that's what we're all about. Now that you know how much power your office needs, it's time to design the heart of your electrical system, the distribution board. Designing a three-phase DB with 36 circuits. Think of it as the central nervous system of your office's electricity, directing power where it needs to go. First things first, you've got to divide your electrical load into separate circuits. This is like creating different lanes on a highway, ensuring that the flow of electricity is organized and safe. You'll want dedicated circuits for your sockets, AC units, and lighting. Why? Because different appliances have different power needs. For example, your AC units will need their own dedicated circuits because they draw a lot of power. You don't want them causing a power outage every time they kick on. Similarly, your lighting circuits should be separate to ensure consistent illumination, even if an appliance on another circuit trips a breaker. Remember those twin sockets we talked about? They'll be grouped on their own circuits, ensuring that there's enough power to go around. By dividing your electrical load into separate circuits, you're creating a safer and more efficient system. Let's talk about the distribution board. Consider the total circuit for the DB is 36. 100 twin sockets, 5 twin sockets in each circuit. For the power setup, we have a total of 100 twin sockets. Each twin socket is rated for 400 watts. We'll divide these into 20 circuits, with each circuit powering 5 twin sockets. We have 6 AC units, each rated at 2000 watts. Each unit will have its own dedicated circuit using a 32 amps MCB for protection. When designing electrical systems, always add extra capacity for safety. For our lights, we're using 10 circuits, each rated for 500 watts, even though they won't use all that power. This extra capacity helps prevent problems and keeps everything running smoothly. We'll also use 10 amps MCBs to protect these circuits. We're talking about safety now, folks, and that means choosing the right cables and breakers for each circuit. These components are your first line of defense against electrical overloads and potential hazards. First up, cables. The size of the cable you need depends on the amount of current flowing through it. Higher current requires thicker cables. Think of it like a water hose. A larger hose can handle more water flow. Now, let's talk breakers. These little guys are your safety net. They automatically interrupt the flow of electricity if a circuit becomes overloaded, preventing damage to your equipment and, more importantly, keeping you safe. Each circuit needs a breaker that matches its capacity. For example, a 15 amp circuit needs a 15 amp breaker. Choosing the right cables and breakers is not a guessing game. It's about matching the components to the specific electrical demands of each circuit. Remember, safety first. Let's explore how we select the right cables and breakers for our circuits. For power circuits, we use a 16 amps MCB with 4 square mm cable to handle the load safely from multiple twin sockets. For our lighting circuits, a 10 amps MCB with 2.5 square mm cable provides the perfect balance of protection and efficiency. And for the AC units, we go with a 32 amps MCB and 4 square mm cable to ensure they get the power they need while staying protected. Choosing the right cables and breakers is key to ensuring everything runs smoothly and safely. Getting the right cable size is crucial. Too small, and you risk overheating and potential fire hazards. Too big, and you're wasting money. So how do you find the sweet spot? First, you need to determine the current that each circuit will carry. Remember that total power load we calculated earlier? We'll use that along with the voltage. Typically 220 volts for single-phase or 380 volts for three-phase systems, and a bit of math to get the current. Don't worry, it's not rocket science. Once you have the current, you can consult a cable sizing chart. These charts, readily available online and in electrical codes, match cable sizes to their current carrying capacity. Remember, it's always best to err on the side of caution and choose a slightly larger cable size if you're unsure. And hey, if you're not comfortable dealing with electrical calculations, don't hesitate to call in a qualified electrician. They're the pros after all. Let's determine the correct cable size for main incoming cable for the three-phase DB. First, we calculate the total load of DB, which comes out to be 57 kilowatt. Using this, we can calculate the current. The formula for current in a three-phase system is current equals the total load divided by the square root of 3 multiplied by voltage and the power factor. With a voltage of 400 V and a power factor of 0.8, the current works out to be about 82.3 amps. Now that we know the current, we can choose the cable size. For 82 amps, a 16 square mm cable is typically recommended. However, for longer distances, it's safer to use a 25 square mm cable to minimize voltage drop and ensure everything operates smoothly. Choosing the right isolator and ELCB. We're moving on to the heavy hitters now. The incoming isolator and the ELCB, or earth leakage circuit breaker. These guys are like the bouncers at your electrical system's door, ensuring that only safe and controlled power gets in. The incoming isolator is like a master switch for your entire distribution board. It allows you to completely disconnect the power supply during maintenance or emergencies. Think of it as a safety kill switch. The ELCB is your bodyguard against electrical shocks. It constantly monitors the flow of electricity and trips if it detects any imbalances that could indicate a ground fault. That means if a faulty appliance leaks electricity, the ELCB will shut off the power before it can reach you. Choosing the right isolator and ELCB is critical. You need to make sure they can handle the total electrical load of your distribution board and provide adequate protection. Again, consult with the electrical codes and, if in doubt, call in a qualified electrician. They'll make sure your electrical system is safe and up to code. Let's start by calculating the total load for the office. In this case, the total load is 57 kilobars. From this, we can calculate the current needed to select the right protective devices, like the incoming isolator and the ELCB. We use the formula, current equals the total load, divided by the square root of 3, multiplied by voltage and the power factor. For a three-phase system with 400 volts and a power factor of 0.8, the current comes out to approximately 82.3 amps. Now, we need to choose an incoming isolator and an ELCB that can handle this load. Since the current is around 82 amps, we should select components rated higher to ensure safety and future flexibility. A good choice is an ELCB and isolator rated at 100 amps. By choosing an ELCB rated at 100 amps, we're not only covering the current needs but also allowing for future expansion without compromising safety. The same goes for the incoming isolator, which should be rated at 100 amps or higher to handle the load and ensure long-term reliability. Section 6. The Big Kahuna. Selecting the right MCCB. Now, let's talk about the big boss of your distribution board, the MCCB, or Molded Case Circuit Breaker. This heavy-duty breaker is like the main gatekeeper, protecting your entire electrical system from overloads and short circuits. The MCCB is responsible for interrupting the flow of electricity if the current exceeds a predetermined level. It's essentially a bigger, more robust version of the smaller circuit breakers we discussed earlier. Choosing the right MCCB is critical. You need one with a current rating that matches the total load of your distribution board. If the MCCB is too small, it will trip constantly, causing annoying power outages. Too large, and it won't provide adequate protection. Again, refer to those handy electrical codes and consult with a qualified electrician. They'll help you choose an MCCB that's just right for your office's electrical needs. Now let's focus on selecting the right MCCB, the Molded Case Circuit Breaker, which will be installed in the main distribution panel or meter board. This is one of the most critical components in the electrical system as it provides protection against overloads and short circuits. To choose the appropriate MCCB, we first need to determine the total load and current. For this office design, the total load is 57 kilowatt, and using the same formula for current calculation, current equals the total load divided by the square root of 3 multiplied by voltage and power factor. With 400 volts and a power factor of 0.8, the current comes out to 82.3 amps. Now, when selecting the MCCB, we need to consider both the operating current and an extra margin to account for potential future load increases or variations in the system. Typically, for a load of 82 amps, we would choose an MCCB rated at 100 amps or higher. This ensures that the breaker can handle any spikes in current without tripping unnecessarily while still providing the necessary protection. But why use an MCCB in the first place? An MCCB is designed to provide protection over a wide range of current ratings, from overload conditions to high short-circuit currents. Unlike standard MCBs, MCCBs have adjustable trip settings, allowing us to fine-tune the protection based on the specific needs of the system. This is particularly useful in large systems like those found in commercial offices, where the electrical load can fluctuate. Additionally, the MCCB's interrupting capacity is crucial. This refers to the maximum fault current that the breaker can safely interrupt without damage. For a distribution board handling significant loads, selecting an MCCB with a high interrupting capacity ensures the system is protected in case of a severe short circuit or fault. In this case, a 100A MCCB with a high interrupting capacity provides both the flexibility and protection needed for the office space's electrical system. It's an essential part of ensuring the electrical system operates safely and efficiently. Section 7. Lights, camera, safety. Following the rules of the electrical road. We've covered a lot of ground here, but there's one more thing I want to hammer home: the importance of following local electrical codes and standards. These codes aren't just bureaucratic hoops to jump through. They're there to ensure the safety and integrity of your electrical system and, most importantly, to protect you and your employees. When it comes to electricity, cutting corners or taking shortcuts is a recipe for disaster. So, what does following the codes entail? For starters, it means using the right materials and components. It means getting the necessary permits and inspections. And it means hiring qualified electricians for the job. Remember, a safe electrical system is a code-compliant electrical system. Don't take chances with your safety or the safety of others. Do it right, do it safe, and do it by the book. Section 8. Bringing it all together. A sample distribution board design. Let's put everything together with a simple example. Imagine a small office with the following electrical needs. Lighting 10 LED lights, each drawing 10 watts. Sockets, 6 twin sockets, each rated for 13 amps. AC unit, 1 3-phase AC unit, drawing 5,000 watts. The total power is 6,660 watts. The total current is approximately 10 amps. For the distribution board design, the lighting circuit will use a 10 amp MCB. Socket circuit 1 will use a 16 amp MCB. Socket circuit 2 will use a 16 amp MCB. The AC unit circuit will use a 16 amp 3-phase MCB. The main isolator will be a 32 amp 3-phase isolator. Note that this is just a simplified example. Section 9. Don't be a DIY disaster. Call in the pros. Now, I know what you might be thinking. Mike, this sounds complicated. Can't I just do it myself? And look, I'm all for DIY projects. But when it comes to electricity, I'm drawing a hard line. This isn't the time to be messing around with wires and breakers if you don't know what you're doing. Electricity is powerful stuff, and it can be dangerous if not handled properly. Incorrect wiring, overloaded circuits, improper grounding. These can lead to shocks, fires, and even death. Trust me, you don't want to be responsible for that. Hiring a qualified electrician is an investment in your safety and the safety of everyone who uses your office. They have the knowledge, experience, and tools to do the job right the first time. So, do yourself a favor and leave the electrical work to the pros. You'll sleep better at night knowing your office is safe and up to code. Section 10. Maintenance matters. Keeping your powerhouse humming. Alright, so you've got your distribution board all set up and your office is humming with electrical goodness. But the job's not done yet. Just like any other critical system, your electrical system needs regular maintenance to keep it running smoothly and safely. Think of it like getting your car serviced. You wouldn't drive around for years without changing the oil or checking the brakes, would you? Your electrical system deserves the same care and attention. So, what does electrical maintenance entail? For starters, you should have a qualified electrician inspect your system regularly. They'll check for any signs of wear and tear, loose connections, or potential hazards. They can also test your breakers and make sure everything is in good working order. You should also be proactive about electrical safety. Make sure your employees know how to use electricity safely and report any issues immediately. And don't overload your circuits. Section 11. Powering your business forward. The bottom line. We've covered a lot of ground here, from calculating your office's power needs to designing a safe and efficient distribution board. The key takeaway? Don't underestimate the importance of a well-designed and maintained electrical system. It's the backbone of your office, powering everything from your computers and lights to your AC units and coffee machines. By following the tips outlined in this guide, and most importantly, by working with qualified electricians, you can ensure that your office has the power it needs to succeed. Remember, safety comes first. Always prioritize safety over cost-cutting or convenience. Invest in quality materials, hire qualified professionals, and follow local electrical codes. By doing so, you'll be powering your business forward with confidence, knowing that your electrical system is safe, reliable, and up to the task.